Okay, so we are available with the second lecture. First lecture completed in the first video. Okay, okay. So if there is no clarity in the video or this lagging, just let me know. Okay. So we are available. So in a single toss, in a single toss, whether event H and T are mutually exclusive or not. So if you take A equal to H, okay, and B equal to T. So I'm just checking whether everything is correct or not on the system. Am I getting complete? So if you see A intersection B is phi. Then it is mutually exclusive. Okay. Now let's move ahead. In a single throw of a die, in a single throw of die, a event is this and this. So can we say that A is equal to 1 2 B is equal to 2 3. So A intersection B is 2. So it is what? Not mutually exclusive. Not a mutually exclusive. Okay. Next, in throwing a die, write whether the event coming off an odd. If you throw a die, coming off an odd is 1, 3, 5, and coming up of an event mutually exclusive. So, and there is a number in which we are getting even 2, 4, 6. So, are they mutually exclusive or not? A intersection B is 5. So it's a mutually exclusive. Okay. Mutually exclusive. Now next, an experiment involving an event involving rolling of a pair of dice and recording the number coming up. A, some greater than 8. So A is some greater than 8. So if we do 1, it will be next is 6, which is not possible. 2, 6, not possible. 3, 6, 9, 4, 5, 9, 4, 6, 10, 5, 4, 9, 5, 5, 10, 5, 6, 11, 6, 3, 9, 6, 4, 10, 6, 5, 11, 6, 6, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 samples. B. 2 occur on either of the die. So if you find that, so here it is either 2 here or 2 occur here. So 2 comma 6 or 1 2 3 2, because 2 2 already occurred here. Yes. 4 2 5262. So if you find that 6 2 is neither not happening in any one of them in A, and if you go to C, so what will happen now? See, the sum is at least 7. The sum is at least 7. So 7 or more than 7 and is multiple of 3. So can we say that more than 7 is 8, 9? So it's a 9, 9, 9, and the next one is 12. Yes, 9, 12. So we have 1, 2, 3, 4, 5 samples. 4 comma 5, 5 comma 4, 6 comma 3, 6 comma 6. So if you see here, A intersection B is 5, because in this we have either of any element is 2, but in this no element 2. Okay, and in second, B intersection C, B intersection C, so neither of this element is 2, so it is still 5. A intersection C, so we have 6 element, so this is not equal to 5. Okay, so now we can say that A and B are mutually exclusive. Yes. B and C are mutually exclusive. Yes. A and C are mutually exclusive. No. Got it? So now this is the time for next question. Yes. So we are going to it in throwing a die. Which of the following pairs are mutually exclusive? Okay. If you go with A. Okay. So the event coming off an odd and the event coming off an even number. So odd and even, odd intersection even is 5. Okay. B. The event coming of an odd and the coming of more than 5. So odd is 5, more than 5 odd is 5, and if it is more than 4, so the intersection will come out to be event A intersection B will come out to have some element as 5. So it's a not mutually, and it's a mutually exclusive. Okay, moving ahead next. So exhaustive event. What will happen if we have multiple event? If we have multiple multiple event, let's say E1, E2, E3, dot dot, En. Okay, if multiple event even up to En, okay, they are the multiple events. And if you try to take E1, E1, E2 union E3, En, which is equal to sample space, okay, then it is exhaustive. Okay, if E1 union E2 union E3 union dot 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 En is equal to sample space, then it's exhaustive. Okay, got it. So now we'll take few examples. In throwing a die, let A be the event number turns up. A be the event number turns up. B be the event, an odd prime turns up. B be the event, an odd prime turns up. C be the event, a number less than 4 turns up. Okay. So let's take A, in which even number turns up 2, 4, 6. B be the event, an odd prime 2, 3, 5. Odd prime, that means 2 is not included. 2 is not included. So A and B, yes. Now what will happen? A is odd prime, C be the event a number less than 4 turns up. That means 1, 2, 3. So whether the event are exhaustive or not. So we are told that A union B union C should be sample space. Sample space in the sense 1, 2, 3, 4, 5, 6. So if you take A union, so 1, 2, 3, 4, 5, 6, all are there. So this is exhaustive. Exhaustive. Okay. Let's move ahead. Three coins are tossed. Describe two events A and B which are mutually exclusive. Okay. So A and B are mutually exclusive. That means A intersection B is phi. So A intersection B is phi. Three coins are tossed. Okay. So we can say that A is H H H and B is T T T. Okay. Second, three events A, B, C are mutually exclusive. Mutually exclusive. Three events are mutually exclusive. What does it mean? Can we say A intersection B intersection C equal to 5? So we what we can consider they are mutually exclusive. So A intersection B equal to 5, B intersection C equal to 5, C intersection A equal to 5. Okay. So if we say A is H H H and this is H H T. We say this one, this is A, okay. Now we are making B. B is, so we have like 8 samples. So why don't we divide it into different samples and we say their intersection is 5. It's a simple. So how should we begin? This is that a sample space is H H H when one T is there, H H T when one T is there, H T H T H H when two T is there, H T T T H T. 3, 4, 5, 6. This should be 8. Yes. T, T, H, T, T, T. So what will happen if in one we are putting this thing, this two. In second we can put the second next to, and in third one we can keep next 4 1 4 H, T, 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 H, T, 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 H, and T, T, T. Okay. So second one is this one. They are mutually exclusive and exhaustive. So their intersection is phi and their union is sample space. So this is the second one. So third one, two events A and B, A and B are not mutually exclusive. Okay, then they will be having something common. So we can say that A is H H H. This is H H T, and B is H H T. HST and TTT. So they are not mutually exclusive. So they have one common, isn't it? And when we go to fourth one, fourth one is A and B are mutually exclusive but not exhaustive. So A is H H H H H T, and B is, we'll take from the last one, T T H T T T. So they are not they are mutually exclusive but not exhaustive. That means A union B is not S. Fifth, three events A, B, and C are mutually exclusive but not exhaustive. Three events. Okay, so this time A is, again we keep H H H H H T, and B as T T H T T T, C as the middle two one, H T T T H T. They are mutually exclusive but not exhaustive. That means A union B union C is not equal to S. But A intersection B is phi, B intersection C is phi, C intersection A is phi. Okay. So in throwing off a die, this question, in throwing a die, which of the following events are exhaustive? Okay, A none. Uh, So an odd turns up. An event, an odd number turns up. 1, 3, 5. A number less than 4 turns up. 1, 2, 3, 4. The number 5 turns up. So if we take A union B union C, it is not equal to sample space, which is 1, 2, 3, 4, 5, 6. Okay, so not exhaustive. B, an event less than 4, that is 1, 2, 3, 4. A number more than 4, this is 5 and 6. So if you take A union B, it is sample space 1, 2, 3, 4, 5, 6. If you go to C, okay, the event, an even number turns up, which is 2, 4, 6. A number divisible by 3 turns up, 3, 6. A number 1 or 2 turns up, so this is 1 or 2. Okay, so number 6 turns up, 6. So what will happen if you go take union of everything? It is 1, 2, 3, 4. 5 is not available. So A union B union C union D. In this 5 does not exist. It should be 1 to 6. So it is not exhaustive. Okay. Okay, I will take care of this side. Okay. Because on this side, throwing a die, which of the following events are exhaustive? An odd number turns up. So in a drawing of a card, in drawing of a card from a well shuffled ordinary deck of playing cards, the events card drawing is spade. Okay, event A, card drawing is spade. Okay, and sample B is card drawn is ace. Okay, so what will happen? So it is not, so A union B is not equal to sample space. Okay, so this is not sample space. That means A is not correct. Equally likely. So when we draw a spade, we'll have 14, 13, 13, 52 upon 4 is 14, 14 4 ja, 13 4 ja. Yes, 13 4 ja. So we have 13 card and we have 52. So we can choose, I mean to say, if we can choose, we can choose any of the 13 card out of 52. In this we can choose any of the 13 card out of 52. So they are equally likely. Probability of A equal to probability of B. Okay. So equally likely. So option B correct. Option B correct. Forming an exhaustive event is, so this is option C. Forming an exhaustive event. So A union B is not equal to S. So this is not correct. Mutually exclusive. So option 1, A intersection B. If we are choosing spade, okay. So A intersection B is phi. That means it is mutually exclusive because the intersection of A and B is phi. Okay, so this is mutually exclusive. We go to option D. None of this. So that is wrong. That is still wrong. So answer is A, B is the correct answer. Next question. In throwing a dice, let capital A be the event coming up of an odd number. Okay, 1, 3, 5. B be the event coming off an even number. 2, 4, 6. C be the event coming up more than 4. 4, 5, 6. D be the event less than 3. 1, 2. A and B are mutually exclusive. So for option A, we'll do A intersection B. So A intersection B, odd and even, which is 5. So mutually exclusive. For exhaustive, we'll do A union B, which should be equal to sample. So if it is 1, 2, 3, 4, 5, 6, so it is correct. So option 1 is correct. B. Okay. Now A and C are mutually exclusive. So A intersection C, we have 5 in common. So not mutually exclusive. So we will not check exhaustive. We'll move to next option. A, C, D are exhaustive. So A union C union D should be sample space. Then it's exhaustive. So A union C union D. 1, 2, 3, 4, 5, 6. Yes, it is exhaustive. D. B, C, D form an exhaustive. B, C, D. So B union C union D. It is 1, 2, 3 is not available. So the element 3 is not available, so not exhaustive. So option C and D not. Option A and C. A and C are correct option. We are moving to lecture 2. For that, we'll tell you to analyze what is the classical definition. So kindly analyze it. I am giving you 1 minute of time. Now we are available again. So now we are again available. Classical definition of probability. So if an experiment result has m plus n outcomes. Okay, which are equally likely, and m outcomes are favorable to an event A, then probability PA is equal to m upon m plus n, which is number of favorable outcome, favorable outcomes upon. Okay, okay, okay. So this should be somewhere drawn upon total number of outcomes. Okay, got it. So this is what it is. In throwing a fair die, the probability that event a number less than equal to 3 turns up. So sample space 1, 2, 3, 4, 5, 6. And now our favorable outcomes is 1, 2, 3. So probability of A is 3 Na upon ns, which is 3 upon 6, which is 1 by 2. Got it? Let's move ahead. In throwing a die, the probability turning up an odd number more than 4. So sample is 1, 2, 3, 4, 6. Sample is 1, 2, 3 up to 6, and favorable outcomes are odd number more than 5, 5, 4, which is 5. So probability of A is n A upon n S, which is 1 by 6. Okay, next. In throwing a pair of dice, find the probability of getting a total of 10. So in throwing a pair of fair dice, the probability of getting a total 10. So sample space will be consisting of, on the first die we can have any number out of 6, and in second die we can have any number out of 6. So total number of sample is 36. Yes, Pranav, tell me. So what will happen? S is 36, yes. Now the probability of getting a total of 10. So sample for getting 10 is what? 4, comma 6, 5, comma 5, and 6, comma 4. Do we have other sample? So what will happen? So what will happen? Probability of getting total A 10 is PA. So total number of sample is 3 and available sample is 36, which is 1 by 12. Okay, so this is the probability. A 5-digit number is formed using 0, 1, 2, 3, 4, 5 without repetition. Find that number is divisible by 4. So a 5-digit number 1, 2, 3, 4, 5. Okay. In order to get, so what, how many 5-digit numbers are possible? Here, just first we are finding sample space, total number of sample space. So here we can have 1, 2, 3, 4, 5, 6. Here we can have 1, 2, 3, 4, 5, 6. And here, so we will choose 6C1. And now we are left with 5 numbers and 1 0 additional here. So again we will have 6C1, 5C1, 4C1, 3C1. So number of sample is 6 into 6 into 5 into 4 into 3. Yes. So we have this much sample space, okay? Now find the probability that number is divisible by 4. So in order for a number to be divisible by 4, the last two digits should be divisible by 4. So if we try to search 1 0, it is not divisible. 2 1 1 1 2 is divisible. Okay. 2 0 is divisible. 2 3 is not divisible. 3 2 is divisible. Okay. 3 4 4 3 3 5 5 3 not divisible. 4 0 divisible. So 4 0 0 4 4 1 1 4 4 2 2 4 2 4 4 2 is not divisible of 2 4 4 3 3 4 5 3 3 5 5 4 4 5 not divisible. So this is the number. When here it is 1 2, yes, we are left with 0 3 4 5. That means, okay, okay, here we have 1 2 1 2 3 only up to 5. 6 is not there. Okay. So here 6 is not there. We have only 1 2 5. Okay. So I think this will get changed. So it is 5C1. Then we are left with 4 digit and additional 0, which is 5C1, 4C1, 3C1, 2C1. So what will happen? This will become 5 into 5, 4, 3, 2. Okay. So now in this, when 1 and 2 are there, we are left with 0, 1, 0, 3, 4, 5. So here 0 cannot come. So 3, 4, 5 will come. So if you see in this, here we have 3C1, 3C1, 2C1. So it's a 3 into 3 into 2. In this case, now 0, 2 is there. We are left with 4 elements. So there could be 4 possible number, 3 possible number, 2 possible number. So it's a 4, 3, 2. When 3, 2 is there, so we'll have the same thing. Same thing is what? 3, 3, 2. Now when we have 4, 0 included, so 4, 3, 2, 0, 4 included, 4, 3, 2, 2, 4 included. So when 0 is not included, 3, 3, 2. So probability of a number getting divisible by 4 is this much amount, total favorable outcome 18 plus 24 plus 18 plus 24 plus 24 plus 18 upon 100 600. Okay, it's a 600. So let's calculate this one. 1 2 3, 18 3 is 54. 1 2 3 72 upon 64 600, which is 6 12 600, which is 6 2 ja 6 1 ja and 100. So this is the probability. A bag contains 4 white, 3 red. A bag. It contains 4 white, 3 red, 2 blue. Okay. A ball is drawn at random. Find the probability that the event the ball drawn is blue or red. So what can happen is that drawing any one of the ball out of 3 plus 2 5 from 9 ball. So the total sample space is what? 5 by 9. So this is it. So drawing, this is what? Probability of blue ball plus probability of red ball. So probability of blue ball is 3 by 9. Probability of blue ball is 2 by 9. Overall it is 5 by 9. Okay, this is all. The letters of word banana are arranged randomly. Then the probability that the word thus formed does not contain the pattern ban. Okay, so we'll say in banana, we'll put a word ban and we have multiple letters as A and A. First tuple, total arrangement. So we have what? For total arrangement we have B, A, N, A, and A. So their arrangement is what? 6 factorial upon 3 factorial 2 factorial. If we calculate this, it is 720 upon 12, which is 60. Okay, so this is the total sample, and in which banana is ban is together. That means when ban together, so we'll have 1, 2, 3, 4. 4 factorial upon 2 factorial, which is 12. So it should not contain this thing. That means, so ban should not, ban complement is what? 60 minus 12, which is 48. 48 numbers, 48 possibilities are there for which it will not have band together. Okay, now probability of band complement is 48 by 60, which is 4 by 5. So this is the probability. 9 cards are labeled 0, 1, 2, 3, 4, 5, 6, 7, 8. 2 cards are drawn at random, put on the table in a successive order, and then the resulting number is read as 0, 7, 42, and so on. The probability that the number is even. Okay, so 2 cards are drawn. So sample space is what? 3, 3, 9 card. So 9 C2 is total number of sample space. Okay, and now what will happen? It should be even. So sample, so favorable, number of favorable event. So for sample for even number, the last number should be containing 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Okay, so if it is 0, 4, 6, 8. Okay, uh, that means out of 5 we should have any one number 5C1, and then we are, if one number is taken here, we are left with 4 number. 4 number is there, so out of 9 one number is selected. No, out of 5 one number is selected, we are left with 4. If we give 4 to the left number are 1, 3, 5, 7. So it's a 4 plus 4, 8. Now we are with 8 number, so there should be any number out of 8. So total 40 even numbers are possible. So probability of even is 40 upon 9 factorial, 2 factorial, 7 factorial. So this is 40 upon 9 into 8, 7 factorial, 7 factorial, 2 factorial. This this getting cancelled. We have, okay, this is 36 and above is 40. It cannot be possible. Yes, 02468. So we choose in 9C2 and their arrangement is 2 factorial. So it's a 2 factorial. It's into 2. So we are getting 40 by 72, which is 5 by 9. Okay. Three persons A, B, and C speak at a function along with 5 other persons. If the persons speak at random, find the probability that A speaks before B, B speaks before C. So what will happen? A, B, C, they are in one order. This is the only order they can speak. So favorable orders. And possible order, this is ABC favorable order with 5%, and we have 8%. This is favorable. So it could be like 8 factorial could be possible, total possible orders, and favorable 1, 2, 3, 4, 5. So what will happen? We'll have 1 gap, 2 gap, 3 gap, 4 gap, 5 gap, 6 gap. Yes. So we'll choose 6C3. Okay. It could be 63 or not. That's our aim. Okay. Mhm. So what will happen? There is no gap. Okay. Or we can break it when A, B, C are together, when AB are together, when AC are together, when so two together, three together, all individual. So when all are separated, yes, then it's a 63. 63 will take 63 space, put them when all are separated. Plus when two of them are together. So three, so two of them. So in this case, two of them cannot be the possibility. The possibility is AB together, BC together. AC cannot be together because in between A and C there is B. So there is only out of three, so we have only two possibility here. Yes, and here when all are together we have only one possibility A, B, C. So we have only one possibilities. And the arrangement of five people is 5 factorial. So now probability of A speaking before B, B speaking before C is 6 factorial, 3 factorial, 3 factorial plus 3 into 5 factorial upon 8, 7, 6, 5 factorial. 5 factorial cancel. So we are left with 8, 7, 6. 6 factorial upon 36. So 6 factorial is somewhere 720. 720 upon 36 plus 3. It is somewhere 23 upon 48 into 7. So this is the probability. A rectangle is shown in a so is randomly selected from the grid of equally spaced squares as shown. Okay. Find the probability that the rectangle is a square. So what will happen in this picture? 4 into 5. 1, 2, 3. This is 1, 2, 3, 4. Now what will happen? We can have one square this way. Okay. We can have 1 into 1 square. We can have 2 into 2 square. We can have 3 into 3 squares. we can have 4 into 4 square. 4 into 4 square. Yes. Now what will happen? So total square is, if it is 1 square, so can we say 1, 2, 3, 4, 5? 5 into 4, which is of one sided. If 2 2 square, can you say it's just a 1, 2, 3, 4? 4, 1, 2, 3. 4 into 3. Similarly, 3 into 2, and it's a 2 into 1. If we find it, it's simply what? 20, 32, 38, 40. 40 such squares are possible. Now, how many rectangles are possible? So, total possible rectangles. So, total possible rectangles. So, what can happen? All those squares which are correct. Let's take like rectangle could be 1 into one sided. 1, 2, 3, 4, 5. So 5 into 4. 5 into 4 plus length is 2, breadth is 1. That could be 1, 2, 3, 4. 4 into 5. 4 into 4. Okay, it's like 4 into 4. Similarly, 3 into 4, 2 into 4, 1 into 4. Now, if we go with if we go with like this, uh, length is 1, width is 2. So it is what? 1, 2, 3, 4, 5. 5 into 3. Okay. So width is 2. 5 into 3. Width is 3. 5 into 2. 5 into 1. Okay. Now width is 2 into 2. So we already got that is 4 into 3. Width is, so we took length 2, breadth 3. Yes, breadth 2, length 2, width 2. Now it's a length 3, width 2. So 1, 2, 3, 3 into 1, 2, 3, 3 into 3, 2 into 3, 1 into 3. And similarly, if we go that side, so width is 3, length is 2. So it is 1, 2, 3, 1, 2, 3, 4, 4. So it's like 4 into 2, 4 into 1. Now similarly, if we see the rhythm, okay, the rhythm is coming out to be what? It is 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. And this is 4. Yes. Similarly, 4, 3, 2, 1. It's a 3. 4, 3, 2, 1. It's a 3. Similarly, it will come out to be 3, 2, 1. It's a 2. And then similarly, 2 plus 1. It's a 1. And the next one is what? 5 is there. 1 plus 2 plus 3. 4 is there. 2 plus 1. 3 is there. It's a 1. Is it so? It was 4. So if we find the sum of total rectangle, total rectangle is what? Uh, it is simply summation of is 9, 12. No, it's like 5, 5, 5 into 6 by 2, 15. Yes, 15 into 60 plus 4 into 5 by 2, 30, 60, 30, 15, I think. 12, okay. It is what? 3 into 4 by 2, 12. And it's a 3. And that side it's a 3 into 4 by 2. This sum. So 12 by 2, 6, 30. 12, 3. So it's simply 60, 30, 30, 60. 60, 60, 120. 120 plus 60, 180. And this is 40. So probability of getting square is 40 upon 120, 180, which is 10 4 ja, 10 18 ja, 22 ja, 2 by 9. This is the probability of getting square. So this is total possibility of rectangle and this is possibility of square. Now this second part we will do here, okay? Three of the six vertices three of the six vertices of a regular hexagon are chosen at random. Okay, they are chosen at random. Then the probability that the triangle with three vertices is equilateral triangle is P, then 100. So what is happening here? If you see the picture, this is a hexagon, regular hexagon. This is a regular hexagon. Mhm. So we have to choose 3 point. One, two, three. In this way or whatever, however we can choose. Okay, we don't know the process, and it should form out to be a equilateral triangle. One thing, total possibility. Total possibility is 6C3, okay, and 4 equilateral triangle. If we see, if we choose this 2 point and maybe any other point, this point, so this is the center, and if this distance is r, this distance will be r, and this is r. Okay, so if we choose anything, if we connect these two length, and if we make it this, what is going to happen is that this is r, but this is more than r. This length is more than r. Okay, so this length is more than r. Okay, this distance is more than r. So how to choose it? So now we will move this point to this point. Okay, so we'll have a, b, c, d, e, f. If we take one gap in between, we choose a, c, e, then it is going to be equilateral. Similarly, we choose b, d, f. This is going to be equilateral. So for equilateral triangle, we have only two possibilities. So possibilities of equilateral triangle is 2 upon 6 factorial, 3 factorial, 3 factorial. So this is 2, 6 factorial is 720. This is 6 into 6, which is going to be 1 by 10. Okay. Now we are moving ahead. Okay. A 9-digit number using the digit 1 to 9 is written randomly without repetition. The probability that the number will be divisible by 9. So what will happen? So sum of. So what will happen? We'll have to first know the divisibility criteria for 9. So if the sum of its digits are divisible by 9, yes, if sum of its digits are going to be divisible by 9, sum of its digits should be divisible by 9. So let's add the sum. So sum of numbers is n plus 1 by 2. So n is 9 into 10 by 2, which is 9 into 5. So it is divisible. So we have to check what's the probability. Okay. So what's the probability of that number? So I think it's the one probability. So all possibles, all possible numbers are 9 factorial, and all favorable all favorable is 9 factorial. So probability of 9 divisible is 9 factorial by 9 factorial. I think which is 1. Entries of 2 into 2 determinant from sheet minus 1 1. The probability that determinant has 0 value. So total determinant possible is, we have two place. So here any two digit can come, here any two digit can come, at this point any two digit could come, any two digit could come. So we have 2 to the power 4, or we can say 2 2 2 2, which is 16. Now the determinant value should be 0. So total favorable. If we take determinant as A, B, C, D, it should be 0, which is AD minus BC. Okay. So what will happen when we put A equal to 1 and D equal to 1? In order to get 0, if B is 1, C should be 1. If B is minus 1, C should be minus 1. Okay. If A is 1, D is minus 1. Then if B is 1, C should be minus 1. If B is minus 1, C should be 1. Okay. If A is minus 1, D is 1, so we will have the same two cases. This same two cases for the same one. And if A is minus 1, D is minus 1. So two same cases of 2 from here. Okay. We can see that if this is positive, if they are same, they should be the same. So two possible condition. If they are different, they should be different. So two possible condition. And their permutation is 2. So one, so same could be plus minus, different could be plus minus. So we are getting 1 2 3 2 2 4. From here we are getting 2, this 2 2, and this is 2 2. Yes. So overall 2 into 4, 8 possibilities. So probability of getting 0 is 8 by 16, which is 1 by 2. In this question, if an integer q is chosen at random in interval minus 10 to 10, then the probability that the roots of the equation are real. So q is chosen randomly from minus 10 to 10. The probability that the root of the equation are real is. So for root to be real, okay, d should be bigger than equal to 0. So d is what? Q square minus 4ac. It should be bigger than equal to 0. If we go further, it is q square minus 3q minus 4 bigger than equal to 0. If you go further, it's a q minus 4q plus 1 bigger than equal to 0. So from here, can we say that Q belongs to minus infinity to minus 1 included, union 4 to infinity, but we are given it should be from minus 10 to 10. So can we say it is officially minus 10 to minus 1 union 4 to 10. So can we say that Q has 10 digit and 7 digit, 17 possible values. Okay, so they have 17 possible values. So probability P real is 17 by total sample. Total sample is 21. This is the probability. Now we are moving to this question. At random in interval minus 10 to 10. Then if Q is chosen randomly from minus 10 to 10. So for root to be real, okay, D should be bigger than equal to 0. So D is what? Q square minus 4AC. It should be bigger than equal to 0. If we go further, it is Q square minus 3Q minus 4 bigger than equal to 0. If you go further, it's a Q minus 4Q plus 1 bigger than equal to 0. So from possible, so the chance that a 13 card combination, a chance that probability 17 by total sample is 21. This is the probability. The chance that a 13 card combination from a pack of 52 playing cards is dealt to a player in a game of breeze in which 9 cards are of same suite. So out of 52 packs, So what will happen? The chance that a 13 card combination from a pack of 52 playing card is dealt to a player in a game of a breeze in which 9 cards are of same suit is. So what will happen? We have 13 cards. So total possibilities is 52 C13, and now total favorable. So we have 13 spade, 13 red, 13 black, 13 ace. So what will happen? We'll choose 4C1, and out of that we'll take 13C9. Okay, and now we have to choose 4 extra card. So for example, if we choose this one, now we are left this one, so we have to choose 4 extra card. So what can happen is that all 4 are from the same suit. So we can choose 3C1, and we can have 4C1, or what can we do? Okay, yes, by looking options. By looking option, I can say that they are helping us to solve this question very nicely. So from 4C1 we chose and we took 13C4. Now what will happen? We'll consider this as a combination of 39. And out of 39, we are choosing 4. That's all. So probability of 13 card with the given condition is 4C1, which is 4, 13C9, 39C4 upon 52C13. Okay, let's move ahead. A bag contains 7 tickets marked with the number 0, 1, 2, 3, 4, 5, 6. A ticket is drawn and replaced. Then the chance that after 4 drawing the sum of the numbers are 8. So total sample count. Total sample count is 1, 2, 3, 4, 5, 6, 7. 7C4. Total sample count. Now, then the chance that after 4 drawing the sum are drawn 8. So total favorable. So favorable, what will happen for favorable? We'll first go this side. To get 8, what will happen if we have 1, 2, 3, 0? It should be 8, which is not possible in our sample. If we have 0, 0, we are dividing it into two numbers. It is, since 6 is the highest, we have 2. Okay. Now 0, 0, 3, 5. 0, 0, 4, 4. Okay. Can you have any more? It will go this side, it will become 5, 3. So we have 2 factorial. So we can say that total possibilities from here, we can say 4 factorial So their arrangement is what? 4 factorial upon 2 factorial. Same for this one. Same for this one is what? 4 factorial upon 2 factorial 2 factorial. Okay. Now if we divide it into 3 digit, let's take 0, 1. We'll take 1 and we have 6, isn't it? So 0, 1, 2, 5, 0, 1, 3, 4. So if we arrange it, it is normally first one 4 factorial upon 2 factorial, second one 4 factorial simply, and third one 4 factorial. And the last one is 1, 1, 1, 5, 1, 1, 2, 4, 1, 1, 3, 3. Okay, here. Now we keep 2 digit constant. Now we are changing, making changes in the third one also. 2, 2, 3. Okay, and we are making every digit changes. Okay, what will happen if we want to change, we are not able to make any changes. If we shift from 3, if we shift one digit to 2, it will become 3, 2. So we are overall doing the arrangement for this one. It is 4 factorial upon 3 factorial, the first one, the arrangement of this one. Okay, this is 4 factorial upon 2 factorial, the second one. The third one is 4 factorial upon 2 factorial 2 factorial, and from here 4 factorial upon 2 factorial. This is a single 4 factorial upon 4 factorial. So now it's time for us to not go this side and to stay this side. Okay, Probability of getting 8 is first tuple 7 factorial, 4 factorial, 3 factorial. So from here if you calculate, okay, so 4 factorial is what? 12, 12, 12, 24 plus 6. From here we are getting 12, 48. No, it's not 7C4. Okay, wait, what will happen? It will be 7 to the power 4. It will be 7 to the power 4 because any digit is repeated. Yes. So it's like 7 to the power 4. Any 7 digit can come here, can come here, can come here, can come here. So it's 7 factorial, 7 to the power 4. So here we got 48. Now here it's like 4, 12, 4, 16, 16, 6, 22, and this is 12 plus 1, 13. Okay, it's coming out to be something odd. So it's like 49 into 49. So 49 into 49. 9 9s are 81. 9 4s are 36. 44, 36, 1, 0, 4, 2. So I think this is the answer which is going to come. 2401, and here it's like 18, 18, 12, 40. I think we are going to get 165. Let's see. 30, 30, 60, 90, 90, 90, 35. 90, 35 is 125. 90 plus 35 is 125, and it should be getting somewhere 1 465 like that. Okay, are you missing something? 90. There will be more 16, I think. Already taken, okay. So it is going 125 this. So let's check once answer, okay? Just try once, okay? I think we might have gone through something. Next question. A and B throw with two dice. Okay. If A throws 9, then B's chances of throwing a higher number. Okay. So A throws two dice. Okay. So B's chances to get 9. Okay. So the sample could come that if A is getting 3, 6, 4, 5, 3, 6, 4, 5, 5, 4, and 6, 3. Now when they are getting this thing, okay, when A is getting this thing, then B in one of the sample, B should be getting higher number equals, throwing a higher number equals, okay. B should be getting somewhere 4, 6, more than 3, 7 is not possible. Yes, so 4, 6, 4, 6 is possible. 5, 5, 5, 6, 6, 4, 6, 5, 6, 6. So we will have to check it once. Check this thing once, okay? Uh, if A throws 9, the chances of, so the total samples of B is what? 36, and it should be getting more is 1, 2, 3, 4, 5, 6, 6. Okay, and probability of getting sample A. So are they dependent? I'm just trying to watch. If A throws, I'm just trying to look whether it is dependent or independent. Okay. So A will be getting multiple samples if A throws 9. So I'm thinking that it is going to be somewhere independent type of thing. Like chances of B getting higher given that A throws 9. This is B intersection A upon PA. So probability of A is 1 by 9 because they have 4 samples and they have 36 event. So probability of A is what? 4 by 36, which is 1 by 9. And B intersection A, when this is somewhere a bit of tricky question. It is higher level question. Okay, this is higher level question. I don't think this fits. Okay. Let's have a brainstorm. Everyone try who all are online. Okay, just try. A will be getting number equal to 9 and A will be getting number bigger than or less than 9. Okay. So total number of samples will come out to be, he will be getting 36 and he will be getting 36. And when these things are happening, it is what? 1, 2, 3, 4. 4 into 1, 2, 3, 4, 5, 6. Understood? He will be getting any number there. He will be getting the combination of number of this. So here it is 36 outcomes. Here there is 36 samples. So total samples are this thing. So probability of A is 4 by 36. The probability of B is this thing, which is 1 by 6 6 ja 4 9 ja 54. This is the probability. Okay. A and B having equal skills are playing a game of based of 5 points. Okay. Are playing a game based of 5 points. After A has won, after A has won 2 points and B has won 1 point, the probability that A will win the game. So based of 5 meaning the one who will be getting 5 point initially. Okay. So these are higher level question. Okay. So what will happen? A1 2 point, A1 2 points, and B 1 1 points. So how the match would have started if if B started, if B started, B might have lost. That means A1, okay, B lost. One is B won, that means A lost, and the next one A won, A won, because A1 A1, because if A lost, that means B will win. So it cannot. There is only one possibilities here. B lost, that means A won. Okay, B lost meaning A won. A won. Now, if B has 1 point, if we say A again won, then B lost. So what we are simply doing is like we are doing arrangement of 2 and 1, which is 3 factorial by 2 factorial, isn't it? Which is 3. So 3 ways of game has happened up to now. And there could be how much possibilities? There could be win lose win lose win lose. So total 8 possibilities. So the probability has been up to now 3 by 8. Total probability of having 2 win 1 lose is 3, and total number of different possibilities are 8. Okay, and now they have to win the game. Now A have to win the game. Okay, if A would have started, then still there will be the same arrangement, isn't it? A will win or B will win. Who will? So they are no one has started. I mean that they both worked parallelly, and someone lost, someone won. They fought together, one won. So there is no case of starting. Okay, so 3 by 8. Now A has to win. So A has 3A and 3A. Okay, and B has just 1 point. Yes, so B can win 3 win. Okay, so this is the thing that could happen. A has 3 win, B has 3 win. Okay, if A wins 3 times. Okay, now what will happen? If there is a case matlab A is winning, and then B is winning, B is winning, A is winning, then whether B lose or B win here, we don't care. So that is why A will have to be at the end if we are counting the probability. That means we are left with 2A and 3B. So we'll do the combinations of this thing. So the combinations are 5 factorial upon 2 factorial into 3 factorial. Yes, and total could have been in this. So this is the way of winning. Yes, and since they played six games, there could have been 2 to the power 6 possibilities. So probability of A win is 3 by 8 into 5 factorial, 3 factorial, 2 factorial upon 2 to the power 6, which is what? 3 by 8, 5 into 4, 2, 2 to the power 6 is 64. If you see, it is 15 upon 4 2 ja 2 2 ja 4, 256. So this is the possibilities of the match. We are moving to next question, okay? Okay. Now we are on this question, okay? A local post office has to send M telegram, okay? M1, M2, M, M, okay? Now we have N communication and N is bigger than N. So N1, N2, N3, NN. Each telegram is sent over any channel with equal probability, okay? Chance that not more than one telegram will be sent over each channel. So what will happen? Total possible, total possible, total possible is what? It is that this could have any of the n. This could have any of the n. Similarly, this could have any of the n. That means n is m time. Yes, and total favorable. Total favorable is what? We'll choose n c m an arrangement of m factorial. So if we see probability, ability, okay, is ncm m factorial upon n to the power m. So I think first option is correct. Let's move next. Okay, a car is parked by owner. A car is parked by an owner in a parking lot of 25 cars in a row, including his car note on the side. On his return, he finds that exactly 15 placed are still occupied. Then the probability that both the neighboring places are empty. So a car of a owner in a parking lot of 24 car, including his car not at either side. So a car is already parked. So probability of car not at end will be what? Like what will happen? The two place, the two end place, the two this end place. Okay, it should not be occupied. So he will choose 20 C31. Okay, and then 25 factorial upon 25. No, he choose someone and there is 24 factorial, isn't it? Because then 24 cars will be arranging in themselves. Okay, so it will come out to be 23 by 25. Okay, so initial probability of arranging this one is this one. Now now when he returns, okay, he finds 15 cars are still occupied. So 15 cars are still occupied. So probability that neighboring space are empty. So neighboring space are empty. What will happen? See, two 15 spaces are occupied. Okay, so we'll consider that 10 spaces are there right now and 15 cars are there. So what will happen when neighboring is empty? So what will happen? We'll take out two space from here, and we have a car. We'll fit space and space, and this is car together, and now we are left with 8 space plus 15 cars. So what can we do is that we can arrange them. So this is now one body, and we are arranging. So 15 plus 8, 23 plus 1, 24. 24 factorial upon this space cannot be arranged among them. Okay, so it will get divided by 8 factorial, and if we see total arrangement is 25. So our initial, so can we say take it as 25 factorial? It will become 1 by 25 into 8 factorial, which is a very huge probability. Yes. No, it is 25 by 8 factorial by 8 factorial. It is 7, okay? Because see, one car also got added. So it's a 3, 7, 10, 25. It should be 24, okay? It should be 7, okay? So we have few changes in the number, okay? So what will happen? This is 7 space, 7 space. Now we are arranging 23 factorial upon 8 factorial upon 25 factorial upon we'll have 16 cars and 9 spaces, so 9 factorial. So we are going to get 1 by 23, 24, 24, 25, 24, 25, and here 9. So we are here 3 by 200. So what will happen? They have given that their car is parked. So can we think that What are the possibilities of getting car occupied at that point when there is 15 car? So from here we got all the possibilities of arrangement. Okay, so this is a bit of intelligent question. What can we do is that first thing, initially his car was there. So his car would have been somewhere in the place of 23C1. Okay. So what will happen? 23C1. Okay, 23C1. We got it. This is the way it was car was. So this probability was initially this thing. C note add and. So we got 23 and their arrangement was 24 factorial and then 25 factorial. Got it? Now, when he came back, so when he left the place, okay, he left the place. He left the place, okay. He left the place. He left the place. Then what happened? He might have been in any one of the 21 places. He left it. He left it. Then one possibility is that someone beside him would have left. The next two would have left. Okay. Okay, so let's try this question very neatly. Okay. One thing is that first one, two, three, four, 5 up to 25. Okay. He's not on the either side. He's not on the either side. So he might have been on 23C1. So we are finding the samples, okay? 23C1 and then 24 factorial. This is the sample space. This is the initial sample space given. Initial sample space. Okay. Now he returned. He found 15 cars placed. 15 cars placed, and that means what will happen if he is on this corner? Okay, so out of 24 we'll choose 15 car, okay, which are on the place. And 24, in 24 car we have 15 place, we have 10 space, 10 space, 15 car plus one additional car, okay. So out of this we'll give two space to this car, boss car, okay. Two space, one car, two space, this is one identity. So one space, one car, one space, okay. And we have now 8, not 8, it's a 7 space. It's a 7 space, 15 car, one space, one space. Now we will arrange them, okay. So 15 plus 1, 16, 16 plus 7, 23. Their arrangement is 23 factorial, okay, and divide by 7 factorial, okay. The spaces are not getting arranged. And we have 23 C1 and 24 factorial. Now, when he is getting, and the arrangement of initial, this is what? 16 car, 9 space, 25 factorial upon 9 factorial. I think this is going to be most suitable. So let's have 24 factorial, 15 factorial, 9 factorial, 23 factorial, 7 factorial, 23, 24 factorial, 25 factorial, 9 factorial. 24, 24 cancel. We are getting 9 into 8 upon 23. 23 into 24, 25 into somewhere 15 factorial, 9 factorial. So 24 C15. This is the total arrangement. So this much is car total arrangement. This much arrangement, yes. Is it going to be this type of answer? We'll have to check it, okay? We'll come back. Let's move ahead. A 2n digit number starts with 2, okay? A 2n digit numbers, 2n digits that starts with 2, and we have overall 2n minus spaces. So can we say that all digits are prime? So prime digits 2, 3, 5, 7. Okay. So total possibilities is 4, 4, 4, 4, 2n minus 1 time, which is 4 to the power 2n minus 1. Okay. So these are total possibilities. So we are told that then the probability that sum of all consecutive digits of the number is prime. So this is, now we are looking for favorable, okay? If it is 2, this could be 3. If it is 2, 2 to 4, which is becoming an even number, which is not a prime. 2 plus 3 is 5, which is a prime. 2 plus 5 is 7, which is a prime. 2 plus 7 is 9, which is not a prime. So if it is 3, so if we keep here 2, 3 plus 2, 5, that is possible. 3 plus 3, not possible. 3 plus 5, 8, which is not a prime. 3 plus 10, which is not a prime. 5 plus 2, it is okay. 5 plus 3, 8, not a prime. 5 plus 5, 10, which is not a prime. 5 plus 7, which is not a prime. That means after 2, if it is 2 number, so after 2 again it is 2 number. 3 comma 5. So overall we have how much gaps? In 2n numbers we have n gaps. That means if we go with total favorable, it is 2 to the power n. So probability of favorable is 2 to the power n upon 4 to the power 2n minus 1, which is 4 into 2 to the power n upon 2 to the power 4n, which is 4 into 2 to the power minus 3n. So I think option B is correct. A fair coin is tossed 8 times. Then the probability that the resulting sequence of head and tails looks the same when viewed from the beginning or from the end. So from 8 time tossed, okay? 6, 7, 8. A failed coin is tossed 8 times. Then the probability that the resulting sequence of heads and tails looks same from beginning and from the end. That means we'll choose 4 and we'll choose 4. If we come from here, 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 if we come from here, here, here. So what is here? It will have to be here. And what is here? It will have to be here. What is here? It will have to be here. What is here? It will have to be here. So if it is head here, then head here. So we can simply say that if there is two, 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 two possibilities. So this is going to have the same copy. Same copy. That's all. So probability of favorable is 2 to the power 4 upon. So whatever came here, we don't have to think here because it is the same. It is just a multiple of 1 to all the numbers. So this is 2 to the power 4 and total different possibilities is 2 to the power 8. So we can simply say 1 by 16. So simple question. In a regular decagon, decagon meaning 10 sides. Decagon meaning 10 sides. Okay. In a regular decagon, find the probability that the two diagonal choosing at random will intersect inside the polygon. Okay. So some decagon, I will draw the picture. I like drawing. One, two, three, four, five, six, seven, 8, 9, 10. Okay. So it's a regular decagon for us. Okay. So two diagonals chosen at random will intersect inside. So if we choose like this, and then if we choose like this, they are not intersecting. If we choose like this, they are intersecting. Okay, okay. Good case. Higher level question. Okay. So what will happen? What will happen? Okay. So good question. Okay. So what will happen? Mm, we'll try to make some analogy, okay? So 10 sides are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10, if we choose any one, maybe this one. So by leaving this, we will choose any one of this. By leaving two of the either side, we'll choose any one of this. This, this, this. Okay, okay. If we choose this and this, okay, from this point, we have we have 3 points gone. We have 7 points. Yes, so we can have 7 points plus plus. If we choose this thing, we can have 2C1, and then 4 went out, so 6C1. If we choose note next one, we have 3C1, so 3C1. 5 gone, 5C1. It is next chosen. So the sum is 8 only, if you see, okay. When we chose the one number, we were left with 1C1 and 7C1. So it is simply 4C1 and then 4C1. So these are the possibilities, isn't it? So so these are the possibilities, and that could happen from both the sides. If we move from this side or if we move from this side, both the sides same possibilities. And one more thing, these possibilities would not be taken in the consideration, because what is happening when we are connecting this one, okay, at that time this is connected to this one, so all the cases has been counted normally, okay. So 7 plus 12 plus 15 plus 16 upon 10C2 minus minus what, all the sides, because we can choose any of the two length. So 1, 2, 3, 4, 5, 6, 7, and 10. This is the possible outcomes. So we are simply getting 19 plus 15, which is 34. 34 plus 16, 50. 50 upon 10 factorial, 2 factorial, 8 factorial, minus 10. And this is 50 upon 10 into 9 by 2 minus 10, which is 45, 35. And above we are getting 50. So this should be 25, I think, somewhere. This should be getting divided by 2. Let's see, okay. When we choose this one, this point and this point, we had 1c1, and here we had 7c1. So 1c1, this could be connected, this could be connected, this could be connected, this is all okay. Now when we moved here, 2c1, and all the cases again taken. When we moved here, after 5, when we are moving here, it is the same thing going along this thing. Yes. So 10c2 is the way we can choose 2 point. 45 minus 10 is 35, and this is coming 50. If we choose one picture, 1 2 3 4 5 6 7 8 9 10, 1 point, 2.3, 4 5 6 7 8 9 10. If we choose this 2 point, then we move this point, we move this point, this point. Okay, so what we did for 1 point, we did the same thing. Okay, so similarly for this point, it will happen. For this point, if we choose this point and this point, we are going to have one cases like that. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, let's take it, we made it 10 digit. Okay, or we can make it like this, 9 10. Now we'll choose this point and this point. Then we have 1c1 7c1. Similarly, 2c1 6c1, 3c1 5c1, 4c1 4c1. Okay, so it will go more. Okay, further it will go. So we'll say 4c1, now 5c1 3c1 plus 6c1 2C1, 7C1 and 1C1. Similarly, we have 10 different points. Okay, so we have 10 different points. Okay, so if we multiply this with 10, so we will have to do minus of repetition. Okay, so the repetition is what? Repetition is what? When I took this point and I kept moving this one. Now this time when I am taking this one and this one, we are getting same thing, 1C1 and 7C1. Okay, so what will happen? Mm, 1C1, 7C1. Okay, so we are getting 2C1, 6C1. So it will be going like this, yes, up to the same. So overall we are getting 9. So this is favorable, okay, which is 9, 7 plus 12 plus 15 plus 16 plus 15 plus 12 plus 7. Okay, overall we are getting what? 14, 24, 38, 38 plus 30, 68, 68 plus 16, uh, 84. Okay, 84 into 9, 34, 34, 34, 68, 68, 16, 68, 16, 84. Okay, 84. Okay, and total possibilities are less, I think. One diagonal. This is 2 times, I think. What is happening is that when this is joined, this is repeated. So when we are moving from this side, this repetition is minused. And what is happening? when this point chosen and this is taken, again we have the same thing, because total favorable is what? Total outcomes is only 45, is 10 C2, in which we will subtract 10. So this is 45, I think, which is 35 outcomes only. So in 35, can we count the possibilities if it is possible? Don't do that thing, okay? Let's count it, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So one diagonal, there is 1, 2, 3, 4, 5, 6, 7. Okay. So first 7. If you go with the second one, we have this thing. If you go third one, which is this thing. Fourth one, which is this thing. So can we say it is 7, 12, 19, 19 plus 15, 34, 34. Total outcome is 35. Now we have 10 C2. Okay, no, no. The total outcome is more. 10 C2 minus 10 is one diagonal. One diagonal. Yes, there is more possibilities. I understood. There are multiple diagonals possible. So 10 C2 minus 10 is a diagonal. Now when we took 2 points, okay, so we have 8 C2, okay, 8 C2 minus, if you choose 8 C2 minus, what will happen when one point is in between 2 points? Okay, so we'll minus 8 lines when 2 points is in between two things. Okay, so one is there, and this side we have six six lines. So we have total 7, 6. If 3 lines is there, 3 points is in between 2 points. So 3 lines minus, will minus 3 lines, 2 lines there, and we have this side 5 5 points. So in 5 points we have 5 lines. When one, see what will happen. I'm saying that in this, if we have chosen this thing, one point is falling here, and we are left with 5 points. Yes, no, we are 10 sides, so 3 points are there. We are left with 7. Yes, so in 7 we have 7 lines together. So we have 7 lines together. So 8C2 we chose 2 points. Okay, 8C2. One case is that when one point is falling here, we have now 7 points left. So in 7 points we'll be minusing 7 lines. If 2 points are falling under, so we'll have 1 line here and overall 6 line here. So it will be 7 again. If 3 points are falling under, so we have 2 lines and 5 lines, 7th line again. And if we have 4 line falling, then 7, 5 lines falling 7, 6 lines falling 7. 1, 2, 3, 4, 5, 6, and 7 line falling, 7 point falling, then 7. So this is simply 35 into 8 factorial upon 2 factorial into 6 factorial. It's a 28. And we have only 7 lines. Okay, note 7 7 in everyone. It is just 1 7, and we win with the repetition of 7. Okay, 1 7, which is 35 into 21. So we have simply probability of intersection as 84 into 9 upon 35 into 9, 35 into 21, which is 7 12 ja 3 3 ja, 7 5 ja, 3 7 ja, 36 upon 35. Okay. So we are facing some problem in this. We'll come back to it. We are moving ahead. A has three tickets in a lottery containing three prizes, nine blanks. Okay. B has two tickets in lottery, two prizes, six blanks. Compare their chances of success. So what can happen is that in A we have three tickets. So what can we do is that we'll choose 9C3, okay, all lost upon 12C3, and we'll do 1 minus. So not winning is their probability of chances. 1 minus not winning is a probability of winning. It is 9 factorial, 3 factorial, 6 factorial, 12 factorial, 3 factorial, 6 factorial. We are simply getting 1 minus 1 upon 12 into 11 into 10, which is 1320. So 1319 upon 1320. This is the probability of A. Probability of A winning is all lost upon all favorable, and probability of B is what? 1 minus all lost. So 62 upon 8C2. It is 1 minus 6 factorial 2 factorial. No, it's just 9 factorial. Yes, we did something wrong. Calculation wrong, okay? We did some calculation wrong in the initial one. Probability of A winning is 1 minus probability of loss. So 9C3, 12C3. It is 1 minus 9 factorial upon 3 factorial 6 factorial. This is 12 factorial 9 factorial 3 factorial. If we solve it, it is 1 minus 9 factorial 12 factorial 6 factorial. It's again 9 factorial. If you go further, it's a 1 minus 9 8 7, and this is 12 11 10. So we are going to have 3 3 ja 3, 4 ja 4, 2 ja 2, 5 ja. So it is 1 minus 21 by 55, which is somewhere 34 by 55. Okay. PB is 1 minus 6C2 upon 8C2, which is 1 minus 6 factorial, 2 factorial, 4 factorial, 8 factorial, 2 factorial, 6 factorial. We'll get 1 minus 6 factorial, 6 factorial, 4 factorial, 8 factorial. If we solve it further, it is 1 minus 6 into 5 upon 8 into 7, which is 30 upon 56, which is 26 upon 56, which is 13 upon 28. So if you try to find this, it is 0.4, and this is 0.6, 0.5. So PA is bigger than PB. Okay. Point is if we choose 8C2 minus, what will happen when one point is in between 2 points? 6 lines. So we have total 7, 6. 3 lines is there. 3 points is in between 2 points. So 3 lines minus, will minus 3 lines, 2 lines there, and we have this side. So this card question is we have already covered this side. Now we are moving to this one, okay? 5 points. So in 5 points we have 5 lines. When one, see what will happen. Yes. The probability that fourth power of a positive integer ends in lambda. Fourth power of a positive number. Then p lambda, okay? So if any number, we are finding p6, yes, that means last digit is 6. If we go with the 10 digit type of thing, okay, choose 2 points, okay, 8C2. One case is that when one point is falling here, digit with 0 at the end, 7 points left. So in 7 digit points, with 1 at the end, 2 at the end, 3 at the end. So 2 4 just 2 to the power 4, it is going to be 16. We will have one line here. And 0 to the power 4, no 16. 1 to the power 4. 2 to the power 4 is a 16. 3 to the power 4, not 16. 4 to the power 4, 16. 5 to the power 4, not 16. 6 to the power 4, 16. 7 to the power 4, not 16. 8 to the power 4, 16. 9 to the power 4, not 16. 10. Okay, we started with 10, okay, and we have 10 numbers, okay. This is what? 4 by 10. We'll go with P1. 1, 3, 4 is there, 5 not possible, 6 not possible, 7 possible, 8 not possible, 9 possible. P 5 by 5, it is possible only by 5. So 1 by 10, P 0, 1 by 10. So all answers are correct. In this question, so X is be the set containing an element if two subsets A and B of X are picked at random. The probability of A and B having the same element if X be a set containing an element. So X be a set of an element 1, 2, and okay. A be a set, okay, A if two subsets A and B of X are picked. So what will happen? What will happen? What will happen is that total number of total numbers of subsets. So we have n element. Total number of subsets is 2 to the power n. This is the total number of subset, and we'll choose one out of that. 2nc1, and in B we'll choose 2nc1, and they should be having the common cause, they should be having the same element if we choose, okay. So now what will happen? They should not be having the common element, okay. They should not be having the common element. So now we will work for this one, yes, this one and this one. So in A, if A has 5, when A has 5, okay, B can have any number, any subset in this, and if we take intersection, it is going to be 5. Okay, when A has 1, it is left with, what? We are left with 2 to n minus 1 elements, so it's like 2 to the power n minus 1. So they don't have the same element. When it is, so in this case we'll say, so when we are choosing one element, okay, we are saying this as NC1. Now when we choose NC2, okay, we are left with n minus 2 element, so we can have 2 to the power n minus 2. Now if we are choosing NC3, we have 2 to the power n minus 3. So it will go, if we have NCn minus 1, we have 2 to the power 1. Okay, and when we have all element, when we have no element, when we have all element, NCn, so it will have 2 to the power 0, which is 1, only 1, which is 5. So can we say that total probability is what? So total number of, so it is something, if I say you that if it has one element, it has 2 to the power n minus 1. So we have 1 minus, this is 1 minus 2 to the power 2n, and this is the, these all are the rejected one, yes, in which they don't have common element. So we are adding 2 to the power n minus 1, n into nc1 2 to the power n minus 1, nc2 2 to the power n minus 2. So what we are going to do normally, let's see, okay. Total sample is 2 to the power 2n, and we have 5 means there is no element, 5 element, and it then there could be 2 to the power n minus 1 possible subset. So we have to do 2 to the power 2n minus, so 2 to the power n minus 1, okay, plus nc1, and we have 2 to the power n minus 1, nc2, 2 to the power n minus 2, plus nc3, 2 to the power n minus 3, dot dot dot, ncn, 2 to the power n minus n. So if you think this could be written as somewhere 1 plus x, 1 plus x to the power n, 1 plus x to the power n, if you see, is nc0 x to the power 0, nc1 x to the power 1, nc2 x2, dot dot dot, ncn x to the power n. So if you see, this is ncn minus 1, 2 to the power n minus 1, ncn minus 2. So this is nc0, nc0, 2 to the power 0, and it is going up to ncn minus 1, 2 to the power n minus 1, and this is nc0, nc0 x to the power n. So can we say that it is 2 to the power 2n minus, if x is 2, it is 3 to the power n plus 1 upon 2 to the power 2n. So this is the value, okay. Now what will happen? This is 4 to the power n minus 3 to the power n plus 1 upon 2 to the power 2n. We will have to simplify it. So we'll write it 3 plus 1 to the power n, and then we'll open it. So this is the correct answer. We'll have to simplify it and match with the available option. Yes, we will have to match with the available option. We are moving to the next question. A square matrix of order 3 into 3. A square matrix of order 3 into 3 is formed using the element minus 2026, 2016, 0, 2016. Probability of getting a matrix which is symmetric is three into 3. Symmetric matrix, diagonal element 0. So what will happen? Here we can have 3 element, 3 element, 3 element. So the probability is what? In 9 places we can have 2 to the power 9, 3 to the power 9. Yes, 3 at every 9 position, and at this position we have 3, 3 to the power 3. So it's simply 1 by 3 to the power 6. So option B is correct. Option B is correct. Okay. So we got that option B correct. Now if we go to option C, probability of getting a matrix which has maximum trace. So total possible matrices are 3 to the power 9, and maximum trace is 2016, 2016, 2016. So here 2016, 16, 16, and we have 3 to the power 6 in other left places. So we have 1 by 3 to the power 3. So C is also correct. D, minimum trace. So it is also 1 by 3 cube, because the diagonal elements are going to be minus 2016. All the elements are going to be the same. Okay, let's proceed ahead. This is also correct. Okay, so this is IIT advanced question. This is also one of the good question that we are covering. If four whole numbers taken at random are multiplied together, then A, probability that the last digit in the product is 1, 3, 7 or 9 is four whole numbers. Whole numbers meaning if we take last digit could be 10, 10 different last digits are possible. So last digit we have 10C4. So we have 10 different last digit existing, including 0 to 9. So we chose some 0 to 4. So how to get if we have x1, x2, x3, x4? It should be coming out to be 1 or 3 or 7 or 9. So so what will happen? To get 3, to get 1, we have 1, 1, 1, 1, 9, 9, 9, 9, 3, 3, 3, 3. All same number. Okay. So we'll have multiple countings. Okay. 7 7s are 49. Okay. 7 7 7 7. 2 to the power 4, 3 to the power 4, 5 to the 4 to the power 4, 5 to the power 4, 6 to the power 4, 7 to the power 4, 8 to the power 4, 9 to the power 4, 0 to the power 4. Okay. Okay. So from here, if we see, we are if we are if our last digit is 1 or 9 or 3 or 7. Yes, okay. Like if we multiply 1 1, we are getting 1, again 1 1 1 1 1 1, 9 or 81 or 9 or 81. 9 9 3 9 7 1 7 9 3 7. Okay, so what will happen out of 10 if we select? So what will happen, the last digit should be any one of these four. So one is this thing, okay. If we take 3 1, okay, then fourth one is 1. If we take 2 1, then it could be 9 into 9. This is the only possibility, because we have to get overall 1, which is 9 into 9 only, 3 into 3 not possible, 7 7 not possible. If we have 1 1, then 9 9 is 81, 993 not possible, 993 not possible, 997 not possible, 9 7 ja 63, 3 3 are 9, okay. Okay, wait. I want you all to solve this question. I'm giving you 5 minutes first, okay? So I'm giving you 5 minutes, okay? Kindly solve it. No hint. Everyone try. Okay, so in this what will happen? We have to have if four whole numbers taken at a random are multiplied together. Okay, okay. If we want one at the end, the probability that last digit number is zero. So 1 square, 2 square, 3 square is not possible. So if we move with option C, okay. So option C is what? 4 digit could be any number out of 4. So 10 to the power 4. That's total probability. And what will happen? We have 4 digit number. We'll choose 5C1. We'll choose, no, we will have 4 places. 4 places. So in 4 places, we'll choose 4C1. Okay, and we'll put 0 there. So 4C1 is a 0, 0 place, and then we can have any number 10 to the power 3, any number. Okay, next. That means one number should be 0, at least one should be 0. Now when 2 5 are together, so 2 5 are together, then in this case we are not taking 0, then it is 9 9 square. Okay, we took 2 digit to be 9 is 81, 4081. It's simply coming out to be 4081 upon 10,000. Let's break it. Okay, 1 2 3 4. So if we put it 0 and we put any number, so there is no foreseeable type of concept. Okay, so at one point we'll put 0 and anyone can have 10c cube. Okay, and in second case, to get 0 we should be have 5 2 and 5, and the others are we are keeping 9 9. Okay, so 9 square, it's like 1081. This is 1081. No, combinations could be what? 0 with any digit. We don't care. 2 5. In this only already we took 0. Yes. This is 9 9. So we are not getting the similar answer. Okay. So if we go with the first option, the probability that last digit in the product is 5. That means 5 1 1 1 could be there. 5 5 1 1 5 5 5 1 or 5 5 5 5. One thing I could say is that if there is one 5, any number should not be any number should not be even, else it will come out to be 0. So 0, 2, 4, 6, 8 eliminated. And if we put any number 1, 3, 5, 7, so there could be 1, 3, 5, 7, 9. So we can say it's a 5, 5, 5. It's 125. 125 upon 10 to the power 4. This is what I am getting. So option B is not correct. So this is for option B. Option B. Option A. 137 or 9. Mhm. C and D is also wrong. This is the answer for C. Now we are working for A. One, one is 2 time multiply 1. 1 3 time multiply 1. 1 4 time multiplied 1. 3. Oh, what will happen? See, we have 4 places left. If we multiply any one of the number, okay, so what will happen? If we multiply any of the odd number, it is going to come out to be 1379 only. So it's simply 1 2 3 4. 4 to the power 4 upon 10 to the power 4, which is 2 to the power 4 upon 5 to the power 4, which is 16 upon 625. So option A is correct. Option B is correct. Now we are on the next question. Question number 7. 7 digits from the number 1 to 9 are written in random order. The probability that this 7 digit number is divisible by 9. Okay, sum of the numbers should be divisible by 9. So that's a chance. Okay. So 7 digits from the number 1, 2, 3, 4, 5, 6, 7, 8, 9 are written in order. Okay, what will happen? If we find the sum of all the numbers, sum of all the numbers, which is sum of the first n 9 natural number, which is 9 into 10 upon 2, which is 45. So we have to have 7 number. So what will happen is that any number going out of this should be making some 9. Okay, so favorable. So for favorable, in favorable I am writing that which number should be going out. 1 comma 8, 2 comma 7, 3 comma 6, 4 comma 5. Favorable, not favorable. That if this number are eliminated, then we are going to get it as a multiple of 9. 9. Okay. So if we try to eliminate 18, it is what? 9 comma 9. Okay. If we want to eliminate 2 digit, so 9 comma 9 is same. If we have to eliminate some different number, yes. So this cannot be possible. So Total sample. Total sample is what? 9c7 into 7 factorial. So probability of favorable. Nine C7, 7 factorial, and this should not be there. That means we have what? 1 and 8 is not there. So 7 factorial plus 2 7 is not there. 7 factorial. 3 6 is not there. 7 factorial. 4 5 is not there. 7 factorial. Can we say it's a 4 into 7 factorial upon 9 factorial, 7 factorial, 2 factorial, 7 factorial. Can we say it is 4 by 9 into 8 into 2, which is 1 by 9? That's the answer. So p square plus q square. P is 1, q is 9. So p square plus q square is 82. So let's move ahead. A mapping is selected. Wait a second. So we are on this question now. So a mapping is selected at random from all mappings defined on the set A, consisting of three distinct elements.